We're diving into something pretty mind-bending today, the quantum internet. You know, we've all had that feeling, right? That little worry, can our digital lives ever really be private? Well, we're going to explore a technology that promises exactly that. The big question is truly unhackable communication a real possibility, or is it just something out of a sci-fi movie?
Think about it. Every single time you send an email, buy something online, or just shoot a private message to a friend, you're sending bits of your life across this massive global network. So, how can you be 100% sure that you're the only one reading it?
Well, it turns out the problem isn't what you might think. We heard about this from quantum physicist Dr. Tobias Heindel on the Science Talks Under the Microscope podcast. He points out that our data has this hidden weakness, and it's not in the software. It's a deep, fundamental, physical flaw in how our internet is built.
Right. So, this weakness, it's not about complex encryption codes being cracked. No, the problem is actually the light we use to send the data in the first place. Yep, light itself.
Okay, so here's a good way to think about it. Our current data networks, they're like a big, powerful floodlight. An eavesdropper can basically skim off a tiny fraction of that light, just a few photons. And because the beam is so bright, nobody even notices it got a little dimmer. And just like that, they've got a perfect copy of your data while the original message just keeps on going, looking totally fine.
And here's the really scary part. This kind of theft, it's completely invisible. You, the sender, and the person you're talking to, you have absolutely no idea your secure channel has been compromised. None.
Okay, so if the problem is literally baked into the physics of our internet, well, the solution has to be too. We're not talking about just writing better code here. This is about building a completely new, a fundamentally different kind of communication channel.
And this is where everything changes. You see, classical security relies on math problems being really hard to solve. But quantum security? It relies on the laws of physics being literally impossible to break. Any attempt to even look at the data instantly messes it up, which immediately tells you someone is listening in.
As Dr. Heindel says, what you get is a system that's provably secure. Think about it like this. It's not just a stronger lock on the door. It's a lock that sets off a massive, screaming alarm the very instant an unauthorized person even touches it.
So how on earth do you create a signal that's that sensitive? Well, the trick is to create light literally one particle at a time. And to do that, you need something incredible called an artificial atom. What is that? Well, on a tiny semiconductor chip, scientists build this nanometer-sized structure. I mean, it's so small, it's designed to trap and hold just a single electron. It's not really a box, it's more like a tiny custom-built quantum cage.
So you've got this electron trapped in its little box. Then you let it recombine with the space, something physicists call a hole. When that happens, poof, it emits one single indivisible particle of light, a single photon. And that's the whole secret. You can't secretly copy part of a signal when the signal itself is the smallest possible piece it can be.
Okay, so this tech is obviously a huge deal. Which brings us to the big question, right? How far off is a full global quantum internet? When can we all use this?
Well, according to Dr. Heindel, we're going to need to be patient. He calls it a mission for a decade and longer. And the reason is simple. You can't just flip a switch. It means building an entirely new layer of physical infrastructure, basically from scratch. But hey, a full-blown internet isn't the only way to use this. What about today? What's possible right now? Get this, early versions of these systems are actually for sale right now. But we're talking about very specific uses. Think of it as a super secure point-to-point link, maybe between a bank's main office and its big data center. But, and this is a big but, getting access is not cheap. Right now, the cost to set up just one of these secure links is, well, it's about the same as buying a house. And you're not getting a tiny little USB stick either. The hardware you need to run just one end of that connection, it's the size of a full 19-inch server rack. You know, for scientists like Dr. Heindel, it's really a privilege just to be part of building this foundational knowledge, the stuff that the next generation of scientists will build on. So yeah, a full quantum internet might be a decade or more away, but the race to create it is absolutely happening right now. And it leaves us with a pretty urgent question, doesn't it? In a world where cyber threats are getting worse every day, can we really afford to wait?